Hi, welcome to this lesson on calculus derivative laws. Let's have a look at question 6. We're given a function g of x as 4x cubed plus a half x squared minus 7x plus 3. We want to find the value of f prime evaluated at 1. So you can see this is different from saying f prime of x equals 1. That's very different. So this one here in purple, f prime x equals 1, is saying at what point will the gradient of the tangent line equal 1? This one here is saying we're now going to find the gradient value at the point x equals 1. So there's a difference in the interpretation. You just got to make sure that you understand that difference, right? So first of all, we need to find the derivative function, g prime of x. So I can use my derivative laws. It's going to be the derivative of 4x cubed plus the derivative of a half x squared minus the derivative of 7x plus the derivative of 3. Okay, I can use the power rule here. 4 times 3 is 12, x squared. Okay, 2 times a half is 1. And then 2 minus 1 is 1 in the exponent, so it's just x. And then 7x, if take the derivative there, we're just going to get minus 7. And then the derivative of a constant, 3, is 0. So we're left with 12x squared plus x minus 7. So now the derivative evaluated at x equals 1 is going to be 12 times 1 squared plus 1 minus 7. So that's going to be 13 minus 7, which is 6. So the interpretation here is whatever that graph looks like, that cubic graph, at the point x equals 1. So if you plug in 1 here, what are you going to get? G of 1 is 4 times 1 cubed plus a half times 1 squared minus 7 times 1 plus 3. You can see how these two are very different from each other. This is the function evaluated at 1, so that's the coordinates on the graph. And this g prime one here is going to tell us what is the gradient, which is 6, of the tangent line. Okay, so that's the interpretations. We just got to make sure we interpret these things correctly. So it's going to be 4 plus a half minus 7 plus 3. Well, 4 plus 3 is 7 minus 7. So that cancels. So you're just left with a half. So at 1, you get a half. So at this point here, when you look at the tangent line of whatever that graph looks like, the gradient at that tangent line is going to be 6. All right, that is what the interpretation is for this derivative here. All right, so that's how we would do this type of question. I'll see you in the next one.